Okay, so imagine if your phone could process data so fast it feels instantaneous, last for days on a single charge, and never get hot enough to burn your hand. Sounds like sci-fi, right? But what if I told you this breakthrough at Rice University might be the first domino in making that sci-fi a reality? Let me explain why this discovery about altermagnetism isn't just another boring physics paper, it's a potential revolution for every device we rely on. /n/n. Alright, let's break down the basics. We've all heard of magnets, right? But here's what blows my mind. Scientists just unlocked control over a third type of magnetism we didn't even fully understand until recently. Altermagnetism. Let that sink in. For centuries, we thought we'd mapped all the fundamental magnetic behaviors in nature, and then boom, 2023 rolls around and physicists realize there's an entire category hiding in plain sight. It's like if someone told you gravity had a secret twin you could use to fly. /n/n. Now, here's where this gets personal for all of us. If you've ever felt your phone heating up while streaming or gaming, you've experienced the literal bottleneck of modern computing. That heat. It's wasted energy. Ferromagnetic materials, the ones we use in basically every electronic device, leak energy as heat because their electron spins aren't perfectly coordinated. Antiferromagnets fix some of that, but they're like a locked toolbox, hard to control precisely. Altermagnets, though? They're the Swiss Army knife we've been waiting for. They combine the best of both worlds, the controllability of ferromagnets and the efficiency of antiferromagnets. But until now, we couldn't even see their true structure clearly, like trying to study a tiger in a cage full of zebras. /n/n. What makes this experiment genius? They basically gave the material a yoga stretch. By applying uniaxial strain, imagine pulling taffy in one direction, they forced manganese telluride into a single magnetic domain. Think of it like tuning a guitar string. When everything's aligned perfectly, suddenly you can hear the pure note. Before this, scientists were hearing a cacophony of overlapping magnetic signals. Now they've isolated the note of altermagnetism. And get this, the sharper signal they found in the anomalous Hall effect. That's not just a lab curiosity. That's the equivalent of finding a hidden gear shift for electron flow. /n/n. Let me geek out for a second. The fact that strain can reverse electron polarity without changing temperature. That's wild. Normally, you'd need to cool something colder than dry ice to tweak magnetic properties like this. But here, a tiny 1% physical stretch does the job of a 150-degree temperature swing. That's like swapping a blast freezer for a rubber band. Why does this matter? Because engineers can't exactly build smartphones with mini refrigerators inside. But they can design chips that flex microscopically. We're talking about devices that reconfigure their own magnetic properties on demand. Think adaptive processors that physically reshape their electron flow mid-task. /n/n. But here's the question keeping me up at night. Are we looking at the dawn of straintronics here? Like how semiconductors birthed the digital age, could this be the first chapter in a new era where mechanical forces and electrical currents shape computing? Imagine foldable laptops that optimize their internal magnetic structure as you bend the screen, or neural networks that use physical strain to mimic synapse plasticity. Yeah, I'm speculating, but isn't that what science is for? /n/n. So next time you feel your phone getting hot, remember, somewhere in a lab, a scientist is stretching a tiny crystal and grinning like they've just discovered a new way to bend reality. Because that's exactly what they're doing. And if this pans out, the future might not just be faster, it'll be fundamentally different.